Are you an anthropology enthusiast or a UGC NET aspirant aiming for success? You've landed in the right place. Welcome to ANTHRONET Academy. At ANTHRONET Academy, we specialize in simplifying anthropology concepts, tackling tricky MCQs, and guiding you through comprehensive preparation strategies for UGC NET and beyond. With engaging content, insightful lessons, and a community of dedicated learners, we're here to make your journey not just easier but exciting. Subscribe now and take the first step toward mastering anthropology and achieving your academic goals. Unit 2 Topic 2.4 Part B Extinct Primate. Extinct lemurs. Giant lemurs, subfossil species, Madagascar. 1. Megalodapus, koala lemur. Megalodapus, also known as the koala lemur, was a genus of extinct giant lemurs that lived in Madagascar. These lemurs were part of the island's unique and diverse megafauna, most of which disappeared after the arrival of humans approximately 2,000 years ago. Here's an overview of Megalodapus. Key features. Size. Megalodapus was significantly larger than modern lemurs, weighing between 50 to 85 kilograms, 110 to 187 pounds, comparable to a large koala or even a small chimpanzee. Appearance. Short limbs and a robust, stocky body. A relatively small brain compared to its size, suggesting limited cognitive abilities. A long, narrow snout with large nasal cavities, which may have supported an acute sense of smell. Specialized hands and feet with strong, curved fingers and toes for grasping branches. Dense bones that supported a slow-moving, arboreal lifestyle. Habitat and behavior. Habitat. Megalodapus inhabited Madagascar's forests and was primarily arboreal, though it may have occasionally ventured onto the ground. Diet. It was herbivorous, feeding on leaves, fruits, and possibly bark. Its teeth and jaw structure suggest it was well adapted for chewing tough plant material. Behavior. Likely solitary or living in small family groups, it moved slowly through the trees, similar to a modern-day sloth or koala, hence its nickname. Extinction. Timeline. Megalodapus is believed to have gone extinct around 500 to 1,000 years ago. Causes of extinction. Human activity. The arrival of humans in Madagascar led to habitat destruction through slash-and-burn agriculture and hunting. Slow reproduction. Like many large animals, Megalodapus likely had a slow reproductive rate, making it vulnerable to population declines. Environmental changes, forest loss and fragmentation further exacerbated their decline. Scientific importance. Evolutionary insight. Megalodapus provides crucial information about Madagascar's unique evolutionary history and the diverse adaptations of lemurs before human impact. Conservation lessons. Its extinction serves as a warning about the fragility of island ecosystems and the impact of human activities on biodiversity. 2. Archaeolemur, monkey lemur. Archaeolemur, commonly referred to as the monkey lemur, was a genus of extinct lemurs that once inhabited Madagascar. It exhibited traits that were a blend of both monkeys and lemurs, giving it its nickname. This genus is part of Madagascar's unique megafauna, which largely disappeared following human arrival on the island. Key features. Size. Archaeolemur was medium to large in size, weighing approximately 15 to 25 kilograms, 33 to 55 pounds, making it significantly larger than most modern lemurs. Appearance. A robust and stocky build, with limb proportions suggesting both terrestrial and arboreal habits. Teeth resembling those of Old World monkeys, with adaptations for processing hard and abrasive foods like seeds and tough plant material. A relatively large skull with a short face compared to other lemurs, indicating a strong bite force. Habitat and behavior. Habitat. Archaeolemur likely lived in a range of environments, including forests and open woodlands, suggesting some degree of ecological flexibility. Diet. It was primarily frugivorous and folivorous, with evidence suggesting it could also consume hard seeds or nuts, thanks to its robust jaw and molars. Behavior. Semi-terrestrial, spending time both in trees and on the ground. Likely diurnal, active during the day, unlike many modern lemurs, which are often nocturnal. Its social structure remains unclear, but its traits suggest it might have been more solitary or lived in small groups. Extinction. Timeline. Archaeolemur is thought to have gone extinct approximately 500 to 1,000 years ago. Causes of extinction. Human activity, hunting and habitat destruction were major factors, as with other members of Madagascar's megafauna. Environmental changes, forest clearance for agriculture and other human activities disrupted its habitat. Slow reproduction. As with many large lemurs, its reproductive rate likely could not keep up with the pressures of human impact. Fossil evidence. Fossils of Archaeolemur have been found in several locations across Madagascar. Two main species have been identified. Archaeolemur edwardsi. Archaeolemur mashori. Their remains provide insights into their diet, behavior, and ecological role. Scientific importance. Evolutionary insight. Archaeolemur bridges the gap between lemur-like primates and monkey-like traits, showcasing the diversity of lemur evolution in Madagascar. Conservation lessons. Its extinction highlights the impact of human colonization on island ecosystems and serves as a reminder of the need for conservation efforts to protect Madagascar's remaining lemurs. Extinct monkeys. New World monkeys. Capra, late Pleistocene. Capra is an extinct genus of large-bodied, arboreal primates that lived in the tropical rainforests of South America during the late Pleistocene epoch. It is named after the mythological Brazilian forest spirit Capra, reflecting its arboreal and forest-dependent lifestyle. The discovery of this genus has provided valuable insights into the diversity of New World monkeys during prehistoric times. Key features. Size. Capra was one of the largest known New World monkeys, with an estimated body weight of about 20 to 30 kilograms, 44 to 66 pounds, comparable to modern howler monkeys, alouatta, or woolly monkeys, Lagothrix, though significantly larger. Appearance. Long limbs adapted for climbing and swinging through trees. A robust body structure, suggesting it was well suited for an arboreal lifestyle. Large canines and other dental features indicating a diet that likely included fruits, leaves, and possibly seeds. Habitat and behavior. Habitat. Capra lived in the dense rainforests of Brazil, relying on the forest canopy for food and shelter. Diet. Its teeth suggest a diet that was largely frugivorous, fruit-based, with occasional consumption of other plant materials. Behavior. Arboreal and likely an expert climber. Social behavior remains speculative, but based on its modern relatives, it may have lived in groups and had a complex social structure. Fossil evidence. Discovery. Fossils of Capra have been found in cave systems in Brazil, particularly in Lagoa Santa, a region known for its rich Pleistocene fossil record. Significance. The fossils are remarkably well preserved, providing detailed information about its anatomy and evolutionary relationships. Extinction. Timeline. Capra is believed to have gone extinct approximately 10,000 to 12,000 years ago, during the late Pleistocene or early Holocene. Causes of extinction. Climate change. The end of the Ice Age brought significant ecological changes that may have reduced its habitat. Human activity. the arrival of humans in South America likely contributed to its extinction through hunting and habitat alteration. Scientific importance. Evolutionary insight. Capra helps fill gaps in the evolutionary history of New World monkeys, showing that the diversity of primates in prehistoric South America was far greater than it is today. Conservation lessons. The extinction of such large, specialized primates underscores the fragility of forest ecosystems and the impact of environmental changes. Old World monkeys. Therapithecus brumpti, extinct baboon relative. Therapithecus brumpti, extinct baboon relative. Therapithecus brumpti is an extinct species of primate closely related to modern baboons and geladas. It lived during the Pliocene epoch, approximately 4 to 2.5 million years ago, in East Africa. This species belongs to the genus Therapithecus, which includes modern geladas, Therapithecus gelada, and several extinct species. Key characteristics. 1. Physical features. Larger and more robust compared to modern baboons. Possessed specialized molar teeth adapted for consuming tough vegetation, such as grasses and seeds. Its jaw and dental morphology suggest a reliance on grinding and chewing fibrous plant material. 2. Behavior and ecology. Likely inhabited open grasslands and savannas, similar to modern geladas, but may have exploited a wider range of environments. Therapithecus brumpti was primarily terrestrial, although it retained some climbing ability. 3. Fossil discoveries. Fossils have been found in regions of East Africa, including the Omo Basin in Ethiopia. These fossils include partial skeletons, skulls, and dental remains, which provide insights into its diet and lifestyle. 4. Comparison to modern relatives. Unlike the modern gelada, which has a highly specialized diet of grasses, T. brumpti had a more generalized diet, allowing it to exploit diverse environments. It is distinguished from other extinct species of Therapithecus by its larger size and unique dental adaptations. Evolutionary significance. Therapithecus brumpti is part of a lineage that demonstrates the ecological diversity of cercopithecids, Old World monkeys, during the Pliocene and early Pleistocene. Its robust features and dietary adaptations highlight evolutionary responses to changing environments, such as the expansion of grasslands in Africa. Extinction. The species likely went extinct as African ecosystems continued to change, favoring other more specialized or adaptable primate species. Extinct apes. Dryopithecus, Miocene ape. Dryopithecus is an extinct genus of apes that lived approximately 12 to 9 million years ago during the Miocene epoch. Fossils of Dryopithecus have been found in Europe, Asia, and Africa, and it is considered one of the early ancestors or relatives of modern apes and humans. Key features of Dryopithecus. 5. Physical characteristics. Medium-sized ape with a body structure adapted for tree dwelling. Possessed long arms, suggesting an ability for brachiation, swinging from tree branches. Its teeth and jaw structure indicate a diet of soft fruits, although some species may have consumed leaves. 6. Significance in evolution. Dryopithecus is often cited as a key genus in understanding the evolution of the great apes and humans. It displays both primitive traits, e.g., smaller brain size, and advanced traits, e.g., flexible shoulder joints, that link it to modern apes. 7. Habitat. Inhabited warm, forested regions. Its fossils suggest it thrived in environments with a variety of fruiting trees. 8. Evolutionary role. Dryopithecus is not a direct ancestor of humans, but rather represents a branch of the ape family tree from which later lineages, such as gorillas, chimpanzees, and humans, might have diverged. Dryopithecus provides essential clues about the adaptive strategies and environments of early apes, contributing to our understanding of primate evolution. The genus Dryopithecus includes several species, and their classification has been refined over time based on fossil discoveries. Below is a list of major species, their discoverers, and the years of discovery. 1. Dryopithecus fontani. Discoverer, Edouard Lartet. Year, 1856. Details: this is the type species of the genus and was discovered in France. It is considered a key species representing the genus Dryopithecus. 2. Dryopithecus laetanus. Discoverer, Miguel Cruzafont. Year, 1944. Details: found in Spain, this species highlights adaptations for arboreal living and is closely related to the ancestors of great apes. 3. Dryopithecus bronchoi. Discoverer, Hermann Schaffhausen. Year, 1916. Details: fossils were discovered in Germany. This species is known for its dental morphology, which suggests a frugivorous diet. 4. Dryopithecus voodooensis. Discoverer, Wu Pan. Year, 1983. Details: found in China, this species indicates the widespread distribution of the genus across Europe and Asia during the Miocene. 5. Dryopithecus africanus. Discoverer, Louis Leakey. Year, 1960. Details: found in Africa, it underscores the connections between Dryopithecus and the potential ancestors of African great apes. Oreopithecus, swamp ape. Oreopithecus, commonly referred to as the swamp ape, is an extinct genus of apes that lived during the late Miocene epoch, approximately 9 to 7 million years ago. Its fossils have primarily been found in Italy and other parts of Europe, especially in swampy or marshy environments, hence the nickname. General characteristics of Oreopithecus. 9. Physical features. Medium-sized ape with a body adapted for both arboreal, tree-dwelling, and occasional bipedal locomotion. Possessed long arms and curved fingers for climbing. Teeth suggest an omnivorous diet with an emphasis on soft plant material. 10. Significance. Oreopithecus is unique among Miocene apes due to its adaptations for a specialized environment and possible bipedal abilities. It is not considered a direct ancestor of modern apes or humans, but represents a unique evolutionary experiment. 11. Habitat. It thrived in swampy, isolated environments, which likely influenced its distinct adaptations. Evolutionary context. Oreopithecus occupies a unique position in the primate evolutionary tree, showcasing specialized adaptations that were likely shaped by its isolated environment in Europe. Its swampy habitat, combined with limited predation and competition, likely drove the development of its distinct traits. Importance in paleoanthropology. Oreopithecus provides insights into the diversity of ape evolution during the Miocene and the variety of ecological niches early apes could adapt to. However, its adaptations were not successful in the long term, leading to its extinction without direct descendants. The genus Oreopithecus is primarily represented by a single, well-established species. Oreopithecus bambolii. Discoverer, Giovanni Capellini. Year, 1872. Details. The only recognized species of Oreopithecus. Fossils were first discovered in the coal deposits of Tuscany, Italy. Known for its unique dental and skeletal adaptations, including potential bipedal abilities and long arms suited for climbing. Its isolated habitat in swampy environments contributed to its specialized evolutionary traits. Pyrolapithecus, potential common ancestor of great apes. Pyrolapithecus is an extinct genus of primates that lived around 12.5 to 11.9 million years ago during the Miocene epoch. It is considered a potential common ancestor of the great apes, hominidae, including humans, gorillas, chimpanzees, and orangutans. General characteristics. 12. Physical features. Fossils show adaptations for climbing and suspensory locomotion, such as a broad, flat ribcage, a stiff lower back, and flexible wrists. Retain some primitive traits, such as relatively short fingers, suggesting it was not a fully suspensory ape. Dental and cranial features align with those of great apes. 13. Significance. Pyrolapithecus is thought to represent an early stage in the evolution of great apes, bridging the gap between primitive apes and later hominids. 14. Habitat. Fossils suggest it lived in forested environments and had a diet of fruits and leaves. Known species of Pyrolapithecus. 15. Pyrolapithecus catalonicus. Discoverer, Salvador Moyasola and team. Year, 2004. Details. Fossils were discovered in Catalonia, Spain, specifically in the town of Els Hostalets de Pirola, which gave the genus its name. This is the only confirmed species of the genus. The fossil specimen includes a partial skeleton with a skull, teeth, ribs, and limb bones, providing crucial insights into its anatomy. Importance in evolution. Pyrolapithecus is significant because it provides evidence of key adaptations seen in great apes, such as increased torso flexibility and reduced reliance on quadrupedal locomotion. It likely represents an evolutionary branch close to the divergence of the great ape lineage, though it may not be a direct ancestor of all great apes and humans. Upcoming topic, 2.4 part, see extinct primate. Thank you for watching. We appreciate your time and support. Subscribe to Anthronet Academy for more engaging content on anthropology. Please like, share, and comment on this video to help us grow. Stay connected. We're here to support your UGC NET exam journey to success.